In this lesson, I'll show you how to solve an exponential equation using the quadratic formula. The question reads, solve the equation 2 to the power of x minus 2 to the power of negative x is equal to 4 algebraically, and then check the solution. The first thing that I'll do is rewrite the second term so that it's a power to a power. Let me demonstrate. We start with 2 to the power of x, that's left alone, and then this term becomes minus 2 to the power of x raised to the power of negative 1 is equal to 4. Next, what I'll do is a substitution. I'll set any letter that I like. I'll use the letter u for 2 to the power of x. The reason why I'm doing this substitution is because u is easier to work with than 2 to the power of x. And eventually, when I find out what u is, I can substitute it back into this relationship and solve for x then. So let's change this to u minus u to the power of negative 1 is equal to 4. One of the exponent laws tells us that if we have a base raised to a negative power, we can rewrite this as u minus 1 over u is equal to 4. Now, I'll find a common denominator between these two terms, and that is equal to u. And the way you do that is you take this denominator, multiply it to the u, and that's how you find it. And then you cross multiply, where you have u times u, that's u squared. 1 times 1, that's negative 1, is equal to 4. I'll multiply both sides by u, that way I get rid of this fraction. If I multiply this side by u, this u will cancel out, and I have to do the same thing on the right side. We end up with u to the power of 2 minus 1 is equal to 4u. Bringing this term over, I end up with a quadratic equation where I have my a term here, my b term here, and my c term here. I can use the quadratic formula to find out what u is equal to. So my a term, my a coefficient is 1, b coefficient is negative 4, and c coefficient is negative 1. I'm not going to waste time doing this using the quadratic formula. Instead, I'll use the function on my calculator. Let's assume that you know how to use the quadratic formula by now. That's accessed by clicking mode 5, 3. Now you put your coefficients 1, negative 4, and negative 1. You should end up with two answers, and we do. Our first answer is 4.23. U is equal to 4.23. And our second u, I'll call this u sub 1 and u sub 2, is equal to negative 0.2360. Negative 0.2360. Now that I found my u values, I can substitute these back into this relationship. I'll start with u sub 1. I have 4.23 is equal to 2 to the power of x. I'll change this back into log form, where I have log of base 2, 4.23 is equal to x. And I'm going to do the same thing for this one, where I have log of base 2, we have negative 0.2360 is equal to x. Now, something we all know about logs is that if this number is a negative, you can never find a solution. Think about it. If I substitute negative 0.2360 into here, there's no possible x value that will give me a negative output, because our base is positive. So we can eliminate the fact that this is even part of the solution. Let's find out what x is. Using our calculator, we can type in log of base 2, 4.23, that gives us 2.08. 2.08. Let's substitute this value back into our original equation to see if it's close to 4. Remember, we did round this number, so there's always the possibility that it could be a little less than 4. Turning on our calculator, we have 2 to the power of 2.08 minus 2 to the power of negative 2.08. This gives us 3.99, and that was exactly what was expected. Therefore, the only solution here is 2.08, and that is how to solve exponential equations using the quadratic formula.